So once you've got orbital notation, the electron configuration is easy. It's kind of a shorthand version of orbital notation. So electron configuration, all we do is we put in the 1s and the 2s and the 2p and the 3s. All those numbers stay there. Okay, but instead of putting boxes there, we're just going to count the number of electrons in those sublevels. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 5d10, 5d4, and 4f10. Okay? 14, right. All right, now, usually there's a tricky sort of thing that happens with electron configuration. Now, I'll accept either way, but that actually what you should do for electron configuration is switch around 4f and 5d. Okay? So really those should be switched around. Because when we did the orbital notation, we filled up 4f first. And we did put one electron in 5d, but then we filled up 4f before we came back and put in these other 3 electrons. So, and I'm assuming that's why. I don't really have an answer for you. I don't know why somebody who's way smarter than me decided to do it that way. But just usually when I see them written somewhere, you have F before D. Does that make sense? I'll accept it either way. I don't think it really matters in the long run. However, when you get to college, some professor may think it matters a lot, so you need to know that. Okay, just trying to help you out. Okay? Now, this is the long version. You got to know how to do it. But there is a shorter version of this where we take the orbital notation for the next lowest noble gas and sort of chunk it. Okay? You know what chunking means? All right, there's chunking like you throw something, but chunking means like another way for chunking is when you kind of put things together. Okay? You chunk information when you learn, for example. So there's a shorthand version called a noble gas electron configuration, where we find the electron configuration for the next lowest noble gas. So let's see, tungsten's here, and if we count our way back through all these elements, our next lowest noble gas is xenon. Okay? And so what we're going to do is find the electron configuration of xenon that's in this. And xenon's electron configuration ends with 5p6. All right? So if we just looked at just this part right here, this would be the electron configuration for xenon, the next lowest noble gas. Did I do that right? Yep, because I'm skipping. All right, got it. Right here. All right? So we're going to chunk all this. Since that's xenon right there, we're going to say xenon right here. And that just takes into account all that stuff. And the reason we do that is because in chemistry, we're mostly interested in what's happening in this upper energy level, this highest, most energy level. That's where all the action takes place for a chemist, in the valence level it's called. Okay? So since we don't really need to spend too much time on this, we can chunk it. And we can put what else remains then. 6s2, 4f, 14, and 5d4. Okay? Does that make sense? There is not a similar chunking method for orbital notation. I did allow you to do a chunking method for the periodic table we made, just for space. But technically, there really isn't one. Right, there's no point in chunking it if we're going to put in all the electrons like that anyway. I mean, that doesn't really make much sense. At least I've never seen it in any textbook. Might be somebody who says it's perfectly okay. I just haven't seen it. All right? So I don't let you do it. Because I don't want you to get into it and do it on a test in a college class and your professor say, wrong, try to help you out there. Got it? Because this class is designed to help you prepare for college.